Well, this is really a note to self, but I had some problems using the PIC kit, and I ultimately figured that the problem was kind of a ridiculous one. I ended up watching EAPBG's blog on programming errors, and to sum up, some of what he discusses is that if you have bad connection problems, particularly VDD, then you just won't be able to compile your code. So I didn't think much of it, and then I actually looked at my chip and I realized I didn't have the chip pushed in all the way. So that was probably the problem. And although it wasn't intuitive, I went to import the hex file. I'm afraid to even do it again, but I wasn't able to import the hex file simply because of the physical problem of not having the chip connected. So I popped the chip in further into the board, and then I was having success importing the hex file. Well, anyway, I didn't plan on making a video like this, but I thought I should just try to cover as much as I can about some of the problems I experienced. So this CB radio project file is really my original saved file, but in troubleshooting I just created another file called Making It Work. There were some issues related to the circuit I built, as far as what I was guessing was maybe part of the program configuration, and particularly this brownout enable pin. And without really explaining it in technical detail, I could sort of tell that the circuit was behaving funny in a way that it was kind of powering on and powering off, almost making me wonder whether the connections on the breadboard were bad connections. But I thought, well, that doesn't make sense. So the chip was kind of powering on and off, and I was thinking, well, that had something to do with the brownout timer. And that's probably true. It probably was the brownout timer. But then it was probably also the fact that oh no, the pin was pushed in, the chip was pushed in at that point. Well, anyway, I think it's better to have this brownout timer off completely. The circuit did work better after that. And then I thought, well, I should have a pull-up resistor on pin 6, which is the pin I'm using as an input pin. This is not the right code. It's sort of correct, but it's not right. I guess the Making It Work file, what's the one I was trying to use? Yeah, I find you really have to, like when you close these, you go to the new file, which is the correct one, and you've got to open source files, click on this, and I suppose the header file in this case is also applicable. Well, anyway, I should maybe discuss the code a little bit. So these are kind of the settings I currently have, and I could pause and look at that if I think I need to study that more. But this xstall frequency, this is 6 zeros, and it seems to be a standard thing that it includes. Maybe this links in the header, don't know. I'm using 3 pins on the IC. So these are the registers for the trace, and it sets pin 6 to an input, and setting it to 1 does that, and setting in these other 2 pins as zeros, making them outputs, is what it is. As outputs. 0 sets them to outputs. When I read the data sheet, it said that port B pins had internal pull-up resistors, so I picked these pins specifically because well, actually the pins are like RB1, RB2, RB0. I picked these specifically because they are in port B and they have pull-up resistors. Okay, so I will explain my code, and it seems to be working for now anyway. RB1 equals 1, RB2 equals 2. So that's these two output pins. Anyway, I got distracted. I'm not a nice man sometimes. Oops, shouldn't be like that. Okay, so RB1 equals 1, RB2 equals 1. This makes them automatically highs at the beginning because they're output pins. You can set them low or high. The input pin, I suppose, only detects. You don't set it low or high, so far as I can understand. So this loop starts off with both of these pins as high. And then I thought I'd like to use an if statement, and I kind of had to look up C programming language as to what an if statement is really doing. And I could have used a while statement, but that would mean that while the pin, well, this relates a little bit to the circuit I built. So I'm getting a little bit of a blip of a high signal, and then I want something to happen. So the if statement made the most sense. I don't want something to happen while this pin is detecting a low or a high. I just want, when a blip happens, do this. So anyway, so if there's a high detected on pin 1, which relates to the practical nature of the circuit I built, then have a short delay, about 1.5 seconds, and then have RB1, which is pin 7, go low. And then have a little delay, a little blip, and then have RB2 go low. And then have a little delay, and then turn them both back on. And then have another delay of 4.5 seconds. So that is long enough for my little message to play from my Arduino. That's only going to make sense to me when I say that, but that should allow the whole message to play. So this, I think, is a partial success. Of course, I've got to put it on a PCB board and solder it up and then see if it all works. But that kind of concludes the program I wrote. So that's a little bit of C programming that I think I pulled off successfully.
Okay, so this isn't going to be the best quality video. I'll try to get this camera on a tripod so my hands aren't so shaky. But anyway, this circuit is not working great because, yeah, the power kicks out for reasons I don't really understand. Is it the breadboard? Is it a loose connection? I hope so, because that would make my life a lot easier. If it's some other thing, well, I don't know how I'm going to troubleshoot that. But anyway, there's a 5-volt supply powering the chip. Hopefully the chip's pushed in all the way. And then the rest of the connections are kind of hooked up, including the oscillator. It's blurry now. The PIC programmer, let me get to focus here. Okay, yeah, so it's kind of screwy and it's not getting the steady power supply or something. I don't get it. But it does what it's supposed to, according to that code. Oh, gosh. What a frustrating piece of crap. Okay, maybe the chip is just not pushed in enough. Whoops. It's not making proper connections with power. Hold on. Alright, well, it does what it's supposed to, and this gets a little jumper of power. That happens, and that's what it's supposed to do. I guess I have to wait and let the program cycle through. It didn't really do what it was supposed to. There is a pull-up resistor on, what is that, pin, what are the outputs? No, pin, not making any sense. Oh yeah, this is the pull-up resistor here on pin 6, which is the input pin, and it's normally got a grounded connection back to ground, so it normally has a low signal after like a 10K resistor. And so then when it actually detects an input, which would be off of this little jumper back to positive, then it really reacts. Not having this 10K pull down resistor, yeah, that's a pull down resistor, isn't it? Was really causing the circuit to do some funny things. So this pull down resistor really helped when I put it in. Yeah, now it's kicking out the power again. What's going on? It does what it's supposed to.